Hi everyone, this is the last video on the conditional identities, and in this video we are going to prove one last conditional identity which kind of looks like this. Cosine square of A plus cosine square of B plus cosine square of C is equal to 1 minus 2 times cosine of A times cosine of B times cosine of C. We have to prove that the left hand side and the right hand side are equal. Now, to prove this identity, we are going to use a few basic trigonometric concepts, and the first one of them would be like this, converting the sum into product. So, cosine of C plus cosine of D can be written as 2 times cosine of C plus D over 2 times cosine of C minus D over 2. And the second concept that we are going to use is multiple angle formula. Cosine of 2 theta is equal to 2 times cosine square of theta minus 1. The third concept that we are going to use is the sum formula here. Cosine of A plus B plus cosine of A minus B is equal to 2 times cosine of A times cosine of B. And the last one that we are going to use is like this. Cosine ratio of a supplementary angle, cosine of pi minus theta is equal to negative cosine of theta. Using these concepts, we are going to prove this identity. So let's get started with the proof. We are going to begin with the left hand side and then eventually we will arrive at the right hand side value. So here the left hand side is equal to cosine square of A plus cosine square of B plus cosine square of C. Let's multiply the first two terms by 2 and then divide by 2. So this is how we are going to write it. So what I have done, I have multiplied the first two terms by 2. Now I am going to divide the whole thing by 2 also. That means I am going to multiply by 1/2. Now if you are thinking why I have left some room here, well, I want to subtract a 1. So here I am going to do minus 1 and then also a plus 1. And with the cosine square of B also I am going to do a minus 1 and a plus 1. So the quantity is still same as before. This is essentially cosine square of A plus cosine square of B. And also we have cosine square of C. So let's keep it outside of the bracket exactly the way it was. Now within the bracket, if you carefully look at it, this becomes cosine of 2A. This portion right here, this portion is cosine of 2A and this portion right here is actually cosine of 2B. So let's now write this as half times cosine of 2A and then of course plus 1 here and then plus cosine of 2B and a plus 1, and then outside of the bracket of course we have plus cosine square of C. Now let's rearrange the quantities inside the bracket a little bit. So we can write it as half times 1 plus 1, so that is actually 2, plus we have cosine of 2A and also plus cosine of 2B, and outside the bracket we have plus cosine square of C. And now within the bracket let's do a little more conversion, so we can write it as half times and then inside the bracket we are going to keep the positive 2 as is, and then plus cosine of 2A plus cosine of 2B can be converted into 2 times cosine of 2A plus 2B over 2 and times cosine of 2A minus 2B over 2, and outside of the bracket we also have cosine square of C. Now what happens inside the bracket? Well, this is actually half times, inside the bracket we have 2 plus 2 times cosine of A plus B. The first one will become cosine of A plus B because 2A plus 2B over 2 is essentially A plus B. So we can write it as 2 times cosine of A plus B times cosine of A minus B, because 2A minus 2B over 2 is actually A minus B, and then outside of the bracket we have cosine square of C. Now let's simplify this little more. Now we are going to remove the bracket and see how that looks. So if we remove the bracket, then this can be written as half times 2, that will be 1, plus again half times 2, that will again become 1. So essentially we are going to have cosine of A plus B times cosine of A minus B, and then also we have plus cosine square of C. And from here, in place of A plus B, I am going to write pi minus C, because A plus B plus C is equal to pi radian. Those are the three interior angles of a triangle. Their sum is 180 degree or pi radian. So I am going to replace A plus B with pi minus C. So we can write it as 1 plus cosine of pi minus C times cosine of A minus B plus cosine square of C. And from here this becomes 1, and then cosine of pi minus C is actually negative cosine of C. So this becomes negative now cosine of C times cosine of A minus B plus cosine square of C. And from here we can see that cosine of C is a common factor between the second and the third terms. So our first term is 1. Then minus, if we take a negative cosine of C as a common factor, so we can say cosine of C, that's the common factor, and then within bracket we will have cosine of A minus B and then minus cosine of C. because we have already taken negative cosine of c as the common factor. So the remaining portion of the third term will be negative cosine of c. Now from here what we are going to do, we are going to keep 1 as is and then negative cosine of c as a common factor, and then within the bracket we have cosine of a minus b, and then in place of c I am going to write like this. I am going to write it as pi minus a plus b, because you know that a plus b plus c is equal to pi radian, so c can be written as pi minus sum of a and b, and from here we can say then this is definitely equal to 1 minus cosine of c times cosine of a minus b, and then minus, now cosine of pi minus something is actually negative cosine of that angle, so we can write it as negative cosine of a plus b. This is that cosine of pi minus theta is equal to negative cosine of theta. I am using that same formula here. So from here we can say then this is equal to 1 minus cosine of c times cosine of a minus b plus cosine of a plus b, and we know that cosine of a plus b plus cosine of a minus b is equal to 2 times cosine of a times cosine of b, so we can write it as 1 minus cosine of c times, this will be 2 times cosine of a times cosine of b. Now finally if we remove the bracket and rewrite it, it is going to look like 1 minus 2 times cosine of a times cosine of b times cosine of c, and that's exactly what we needed to prove. That's the right hand side of our identity. So let me make a note here that this is equal to the right hand side, and hence the identity has been proved. As I mentioned earlier, this is the last video on these conditional identities. In fact, using all these concepts, you can solve any conditional identity like this. In the next videos, we are going to cover a few more remaining topics from the properties of triangle. I hope everything made sense in this video. Thank you for watching. See you in the next video.